The information we've gotten from neuroscience concerning how the brain learns has become significantly more accurate and more useful in the past 15 to 20 years. We're able to see through functional imaging which areas of the brain are metabolically active at any specific time, which means we can see what the brain is doing while it's attentive, when it's bored, when they're stressed, and we could also be monitoring these brain metabolic changes with different interventions. So it means that we can evaluate students, children, adults, when they are, for example, in a state of high stress, and using various strategies that they practice to self-calm, and watch how the flow of information through the brain changes. So with the increased amount of information, it's important and valuable for consumers to be aware, because there's never going to be anything, and has never been anything, that has been proven in the laboratory that can be taken as proof of something that will work outside the laboratory. There's only one variable in the laboratory, it's strictly controlled. But although we see support for certain things based on laboratory testing, we can only make correlations to what will be most likely to benefit a learner beyond the classroom. So beware of anything that says proven by lab research. When information is stored in the brain, it's interesting that no matter what type of sensory modality the information is learned by or through, the information is stored ultimately, if it becomes long-term memory, in the part of the brain through which it was first and second and third acquired. By that I mean, if somebody learns something through what they hear by someone speaking, and that information has gone through the process and successfully becomes a long-term memory, that long-term memory will ultimately be stored in the auditory cortex, in the temporal lobe cortex. If they're also learning it or practicing it by movement, then if that also becomes long-term memory, it will ultimately be stored in the parts of the cortex for movement, such as the cerebellum or basal ganglia. If it's practiced or learned also by what they see, same thing, it gets ultimately stored in another hemisphere. What's really great is each of these areas where the information, the memory is stored, connect to one another. So when they're trying to retrieve the information, some people can remember the movements, and that will activate also the memories that are stored about that same topic in the auditory and the visual areas. So multiple modalities of learning and practicing information will increase the storage areas, increase the accessibility, and the likelihood of retaining it for memory. Dopamine is a neurotransmitter that I consider the educator, parent, adult best friend. It's a neurotransmitter of which there are about 200, but this one is strongly associated, when it's increased in levels in the brain, it's strongly associated with a sense of deep pleasure and satisfaction. Also, when dopamine levels are increased, there's increased attention, decreased stress, increased motivation, and perseverance. So it's an overall good thing for dopamine to be elevated, and the types of things that elevate it within the appropriate range, not super high elevation, which happens with some drugs, but within the appropriate range, we see that dopamine becomes elevated in the brain with such things as being read to, movement, positive interactions with peers, the certain music that's appealing, acts of kindness, gratitude, those actually increase dopamine, and it's specifically and particularly elevated with making correct predictions and getting feedback, or achieving challenges. So knowing what we have learned that increases the release of dopamine within the brain, and what happens when dopamine levels are increased, we can use those interventions to promote positive attitudes and positive behaviors. Collaboration is one of the very useful opportunities that we have to engage students' interest, memory, and participation. Because one of the things that raises dopamine is positive interaction with peers, so that's certainly a reason to use collaborative learning. The other is that there's mistake fear is a significant problem, especially after about age 8. Making a mistake in front of others really restricts participation. And participation is critical to developing memory and conceptual understanding. So when someone's in a smaller group, especially if they've been working together and they're working together on an inquiry project that they find compelling and interesting, then their comfort level increases. They're with a smaller group, so it's not taking the risk of saying something in front of the whole class. Now it's in front of just a few people. So they will also have increased time to participate. During an average school day, most students have about 10 minutes of interaction, teacher-student interaction. But in a small group, there's a significant longer period of time that each person has to interact. So there's a positive interaction of the dopamine and the increased willingness to participate and opportunity to participate. There is a reason to particularly consider collaborative, cooperative, interactive group work with adolescents. And it also goes back to what's happening in their brain developmentally with their executive functions and also with their dopamine release. During those adolescent and teen years, the prefrontal cortex is barely wiring in these executive functions such as goal development, delay of immediate gratification, judgment, risk assessment. They're not wired in completely until the mid-20s. So during the adolescent years, there's actually a default network, a stronger network that is particularly powerful. And that's a network that's guiding the brain, guiding the mammal to take risks. And that doesn't seem reasonable. Why would we have something that's guiding us to take risks? Well, it does make sense in terms of animals. When they're adolescent, they're about to be leaving the protection of parents. So it's important for them, while they're somewhat protected, to explore. But we've inherited that same system. So during the teen years, with the system in the brain saying, go ahead, try it, don't think about caution. So we need other ways to help kids experience and take the opportunity to explore, but without high risk. And when they're in small groups, they are working with peers, but they have 4 brains or 3 brains instead of 1. So they'll be able to use some judgment, use some of these skills that 1 or 2 of them can bring up, and have more likelihood of developing this goal-directed behavior and less high risk-taking. The final benefit of it is, once again, dopamine. Dopamine goes up with interaction with peers. In adolescence, dopamine goes up with taking high risks. We don't want that to be the behavior. So we can proactively do things like group work so they will have a high amount of dopamine while they're doing that activity and not go off to get it with high risk behavior.